Now, in order to cache out our subframes properly, we actually need to do a few things in preparation for that. First of all, let's change our substeps here to 4 on the DOP node. I just have this DOP network highlighted, and under the simulation tab, you'll find substeps. Also, while we are here, let's reset the simulation. So always click that anytime you change the substeps. Next, let's go to our global animation options. And in here, we can actually turn off these integer frame values. So if we check that off and we do a step of 0.25, now when we scrub on our timeline, so if we use these left and right arrow keys, you'll notice that we have 1.25, 1.5, and all of those subframes that get hit. So that's good. We have our subframes. Now let's go inside of our simulation. And we actually need to rekey this constant activation. Remember how we had to animate this just to make sure that the mask worked properly? Let's scrub forward here a few frames. And it's going to take a little bit to think about this. Anytime you increase the subframes, remember you're going to have to calculate things in a way that takes 4 times as long. And that's kind of a wacky behavior. Let's zoom in here to where this is at. And I'm just going to use the left and right arrow keys to scrub through. And it looks like on frame 14.66, this is where we need to turn on our constant activation. So I'm going to key constant activation in 1. I'm going to go back 1 frame or 1 subframe and then key it here at 0. Now, if I redo my simulation, it should fix that problem. So, yep, there we go. Okay, we have that. That's looking good. Now, let's go ahead and set up our cache file. So, in order to do this properly, you need to make sure you have the right substeps. I put in 4 right here. And what's actually a better way to do this is by going to our DOP network and doing a relative reference. So, copy parameter, and then under the file cache, paste relative references. We have that there. And then the last thing is to make sure that when you are caching out this geometry file, that you specify $FF. Right now, it's probably set to $F4 in your scene, but $FF will cache out those subframes. So next, we just need to save to disk, and then we should have all of that cached out. All right, so now let's double check our file node, and let's actually rename this here. Right now, it's just saying file 1. Let's copy our base particles and say base particles read, just like that. And what we can do is set our frame here to something down the road. And you'll notice something interesting. It's trying to cook our DOP network. And it really shouldn't be doing that because right now we have our visibility set here. And you might think, well, why is it happening? It's because on this rune geo, this initial geometry, we have this highlighted. So this is a common thing I run into quite a bit. If you want to prevent the DOP network from calculating anything once you're done with it, check out this little brain icon down here. If you turn that off, if you just click it to that little, cross or that little, I don't know, don't do this button, then that will prevent it from actually trying to think about the DOP network. Another thing as well is let's just turn off this rune geo and just check out this rune simmed. Okay, now that we're here, we can just, I'm just going to hold down the right arrow, and there we go. Now we have it playing. And this is exactly what we want, which is great. We have all of our subframes happening now. Okay, so in order for us to get this whole strand effect going, there's a few more things we ought to do. For one, let's make sure that our P-scale is set. That's good. And in order to take advantage of this, I'm actually going to, by the way, change my beginning frame here to like 25 or something, just because I want to be able to preview this. Anyway, we have this attribute randomized. The key node that you need is the trail node. So this trail node does all kinds of really awesome things. Amongst many other things, it will actually create a copy of a particle depending on where it was on a time step. It basically creates a trail of particles or of geometry, whatever you feed into it. So right now our trail length is 2. We did 4 substeps total. So let's try doing a trail length of 4, and then the increment is going to be our 0.25. And by doing this, we now have all of these tiny little points here. And what I'm going to do just for us to test this out quickly is I'm actually going to isolate a set of these points. So I'm going to press S for select. I'm going to press 1, or excuse me, S for select, 2 for points. I'm going to highlight these points right here, hit Tab, and now I'm going to type a blast node. And what we can do with this blast node is just delete things. So if I say delete non-selected, it's just going to isolate this one spot right here. Spacebar F will frame this in, and we can zoom in a little bit. And now we need a way to connect these points. So how can we do that? Well, if we take a look at our geometry spreadsheet, we need something that's in common with all of these different points to connect them with. And the thing that we're looking for is this ID. You'll notice that because we basically have the same particle, it's just a different time step, that all of the IDs are the exact same. So what we could say is that if you belong to this ID, which in this case was 129,800, then draw a line connecting all of those points. That's what we want to say. And the node that is going to allow us to do this is the add node. In a future tutorial, I'm going to go over the add node a lot more in depth. But just for now, let's go to the add node, and we want to create a polygon out of all this. Let's go to the polygons tab, and we're going to select by group. And then we want to say, instead of add all points, we could say add by an attribute. So again, we're adding a polygon, right? That's the thing that we want to add, or thing we want to create here. And the common denominator is going to be the ID. And now if I get rid of this blast node, we will have all of our strands appear just like that. And there you go. Now this is going to error out because actually my time slider down here is showing these 0.31s or whatever. Let's actually do a flip book real fast to see what this gives us. And now that our flip book is all finished up, we have our final result right here. And it's looking pretty cool. So the next step here is to just basically put this all together in the render. It's also still worth messing around a little bit with the marble shader just to give that rune impression with the marble. So in the next lesson, we're going to do that and wrap this whole thing up.